Here we are learning about something called as rectangular glass slab experiment. So I'll give you guys a brief introduction through this experiment. So please have a look at this. So what are we looking at? We are looking at a structure which is rectangular, right? Yes, it's square, which is also a rectangle. And we have a laser light which is kind of got shifted, right? It was supposed to be going in this direction, but it has kind of got shifted, is it not? Right? Can you see that? So a light which was supposed to go in this direction, it has got shifted. So what is happening over here? So what is that we are trying to learn from this? We are trying to learn the idea of refraction again. And we are trying to learn specific to glass slab something called as lateral shift. Okay, so something called as lateral shift. So the word lateral means side, sideways. So whenever we see anything shifting sideways, we can tell it's laterally shifted. So in this case, what is laterally shifted? A light got laterally shifted, is it not? And it got refracted at two different points. Right? These are the two interfaces or the boundaries wherein the light got refracted. So this is nothing but your rectangular glass slab experiment basic funda. So we are trying to learn refraction again and lateral shifting. That's a new concept. So how are we doing it? Is it through this laser experiment? Not exactly. We will use pins. So instead of using, so that was, oh, by the way, this is your oil and this is air. Okay. So this is not a glass slab. This is oil and air, but the funda is the same. This is also rectangular structured, and glass slab is the one which we are picking is also rectangular structured. So we will be using a glass slab which is denser compared to air, optically denser. So what we'll do is we take up a glass slab, we kind of take a paper, glass slab, and we draw a boundary. Right? So once we do this, we kind of keep it aside. Then we pick up a random point and draw a normal first. And at this point we make it as point of incidence and we draw a line. This is your incident ray. We consider it to be an incident ray. Along this line we pin two pins. Okay, so this is pin 1 and pin 2. You can imagine two pins being pinned. Literally, we're going to pin two pins onto this paper. Of course, on the paper it won't stand. We have to keep something which is maybe, how do you put it? Something soft which can get pierced, right? Thermocol basically, yeah, that's what I was trying to figure out, thermocol. So basically the second step would be to draw things and pin. I'm trying to just brief you through what we are going to do. Third step is important, keeping the glass slab back. That's the whole point of drawing this. Keep it back and observe. What is that we need to observe? We need to observe this pin via the glass slab. Okay, so this is the tricky part to understand. So we need to see the pins via the glass slab, and if once while doing this we need to pin two more pins, P3 and P4. Yes, it's kind of weird, but this is what we have to do. So how to do this? Well, we have to pin in such a way that they are collinear. Okay, so they are collinear. So what is collinear? We have studied in math linear equations, not in linear equation actually linear equation also. It can be applicable pretty much everywhere, but this word you come across in coordinate geometry. Okay, which means same line, same straight line. So let me show this and explain, so let me talk about collinearity with the help of a video. So here we are looking at, right, a glass slab and 4 pins. Let me show it. Yeah, so this is said to be collinear. See, can you see that through the glass slab you can see 2 pins, and in front of glass slab we have 2 more pins, right? So all these pins are, now they are collinear, means the front pin is blocking all the pins. So this is your same video picture. Okay, I've just taken a screenshot. So can you see that we have pin 1 in the background, pin 1, pin 2, but this is not seen over here. This is not seen over here because it has got laterally shifted, right? It has got laterally shifted. The light from the pins have got laterally shifted. So that's why they are coming out this way. And in front of that, I have pinned 2 pins, P3 and P4, right? So you can see clearly there are 2 pins, right? So this is the whole funda. And after this, third or fourth, fifth or some step, I kind of lost the count. Yes, I've written it, but the thing which I've typed, I think it's a bit different. So 4th step is to remove all of it. Okay, say we've found the 2 pins. I need to do something. Just a second. Okay. So think that we have pinned the 3rd over here and the 4th over there, right? So we have to remove and draw. Okay, what is the drawing which we are doing? We're going to join this, right, till the interface, and then we're going to join these 2 points. So this is your tracing of the light. So the light from the pen, like over here, we are not able to see it, right? That is because it has got laterally shifted in this way and it's coming out in this way. Okay, right? So the light has got laterally shifted. That's the whole funda, right? So let us do this practically. So next thing is the entire thing, whatever we just discussed, let's do it practically. Okay, so we are looking at step 1. We're taking up a paper, a glass slab, rectangular glass slab to be precise. Then we need to draw the boundary. We should do a better job than what I'm going to do. So you can see till there I'm okay. But yeah, the 3rd one I don't know. I think I didn't put a lot of pressure. So I didn't do a good job over there. Can you see that? Anyways, step 2. Drawing a normal. Then you need to use protractor, and having a specific angle will be helpful if you're measuring and everything. So I think I marked around 25 degree or something. It is 25 degree actually. Then that is your incident ray. So I'm extending the line so that I'll show you guys the lateral shift, right? So do the job at one go. Digitally it's okay, but when you're doing it analog, don't do that. Extend it off so that there's no confusion. So step 3. So I mark 2 pins, point for the pins, and I'm placing them. This is few centimeter apart. Preferably 4 to 5 centimeter would be helpful. So I'm keeping the glass slab back, and this is the tricky part. Okay, so yeah, I have one more view. See, can you see that? I'm trying to place the pin. I'm holding a camera also, so it's not easy. So I'm trying to place the pin. Look at the right side, okay? I hope you guys are doing that so that they're collinear. The lens is blurry, and Yeah, it was a bit tricky to do this. Okay, can you see that? So the 2 pins through the glass slab, don't observe it up above the glass slab, through the glass slab. So I'm not very happy because it's not actually done well. I've not done a good job in this particular video because it's kind of tough to hold a camera and it was not on a high table. Yeah, please observe, let me not talk. I'm trying to make them collinear. Okay, try to keep everything straight, make an angle of 90 degree, all the pins. Can you see that? They're collinear. We need one more pin because we need 2 points to draw a line. Okay, second pin also I'm trying to make it collinear. See, it has to block all the pins. Can you see that? So we can see all the 4 pins as of now. And I'm shifting. And the front pin is blocking all the pins at the back. Right? So once you do all of that, once you're sure of what you have done, remove the pins, remove the glass slab. So you can see my first 2 trials were wrong. I have 3 points over there. But yes, those are the final 2 points. 2 extra points are there. And I'm joining. Yeah, through the glass slab, the light will be traveling in that manner. Okay. Within the glass slab, it will be straight because there is no change in optical density. Right. So overall, okay, so that is your final diagram. Right, of course, this is not the final one. We need to further do quite a few things. Like over here, we need to draw normal at both the ends at point P and Q, if I want to call it. And we can measure the lateral shift, right? Like over here, it's around 1.8 centimeter. Measure the incident ray, refracted ray, and the emergent ray, right? So all of this we need to measure. Okay, basically we are looking at a similar thing. Can you see that? These 2 are quite similar. Rectangular glass slab, so on and so forth. And yes, this is the basic experiment, right? So all the write-ups and everything I'll be showing. So try to make a running note. Whatever you understood over here, try to make a running note. I'll be giving a detailed notes on the entire experiment. This is mainly for understanding. You need not copy the steps. That also I'll be giving in detail. Just try to make a running note about whatever you understood on your own, extra things that you understood. Whatever makes it easy to recall this concept.